Alright, here's a quick video on surface mount soldering. So in the previous video I showed how to do surface mount soldering using just the soldering iron. This one I'm going to show you might be a better, certainly easier, it can be a lot faster way to surface mount solder. But obviously it needs a little bit more equipment. It needs a hot air gun as well as some solder paste. But a lot of those things, hot air guns are actually fairly decently priced. You can get a cheap one that it might work, might do what you need to do, but it's still something more to purchase. All right, so here's the components I'm going to be soldering. Here's just a, see if I can slide this in for reference, for size reference. So there's a penny. So this is a couple of resistors for the diodes. These are LEDs, a couple of transistors, and a couple more resistors, and some larger electrolytic capacitors. So this size resistor is 1206. So let me just put it up here. As we'll see in the microscope, that it's actually, I think, as surface mount components go, it's pretty large. But like if you've never done it before, it's certainly small. So the 1206 refers to the side in imperial. It's going to be in mils. So 1206 refers to 120 by 60 mils. So 0.12 inches by 0.06 inches is the dimensions. Now, I'm also going to be using this solder paste. So this is chip quick, and it works pretty well. Essentially, it gives it's the consistency of toothpaste or maybe peanut butter, and comes in these convenient little syringes, which is a little plastic in there. And the key is to dispense both not too much and not too little bit of solder. So maybe I'll switch over to the microscope and you can see me applying it. So I'm just going to try to eyeball it. So I'm pressing just a little bit. And just a little dab. Could use a little bit more than that. That's probably pretty good. So if you see in the microscope, you can see what looks like little beads. That's actually the solder. It's actually little tiny pieces of, so what I'm using is a lead tin solder. Yeah, so it's 6337, 63% tin and 37% lead. So those are tiny little balls of solder. And it's held together with, basically it's flux. So it's just a flux solder ball mixture. All right, so we got the solder paste placed. So this is going to be, so I'm going to, using some nice pointy end tweezers, place it, and I'm going to just lightly kind of tap it, push it into place. And it doesn't need to be perfectly straight. As we'll see, the surface tension as the solder melts will actually help it pull it into perfect alignment. And fire up the hot air. Now the real challenge is going to be doing this underneath my contraption, well, the cameras and the microscope. As we'll see, so I'm waving it around, see if I can actually get it on both sides. And I see it starts to thin out. Obviously, as it heats up, it loses viscosity. And so I'm just waving it around a little bit to bring it up to temperature. Now I'm up to about 400 degrees C in the hot air. And once it melts, all right, and there we go. That's a nicely surface mount soldered component. And you can see there's I actually got a little carried away. See, not all of the solder melted. See if I can do this. I can see there's just a little couple tiny balls that kind of coalesced, but once we clean it, yes, there's a couple extra ones. So I put a little too much solder paste on there. And you can see up here at the top. Here at the top, there's a little solder ball. You can just pull that right off. So it looks enormous, but in real life, it's quite tiny. So this next component is the LED. So it's nice that you can see this nice little cathode side and anode side indicator. And you can see it's magnified. You can see this actually has the print, the silkscreen print actually has some dimension to it. I'm just going to go in and dab some solder paste on. That's probably too much. Now we'll see with this particular LED. Let's see if I can throw it on my finger and show. See, there's just a little bit of a green mark right there. So that is going to indicate the cathode side. So I'm going to put it down in the same orientation. So again, same process. And just drop. You can see it's not. It's obviously not sitting flat, and if I melted that, it would probably sit flat. It's always a good idea to just kind of tap it down into place. Now, turn the hot air back on. So if I was doing this entire board all in one shot, no, I wouldn't actually do this one component at a time. I would put solder blobs on everything and go ahead and heat the whole board. I don't want to put all the parts through too many thermal shocks or thermal cycles. And there we go. That's something I can watch all day long. Alright, I just realized I put the R2, the wrong resistor, on. Now to remove the component, all you need to do is heat it up. Basically just going to remelt the solder. And just pop right off. Go in there with a little bit of solder wick. Pull that off. And pull that off. And just add a little more. Now I'm going to be careful and grab the correct resistor. Plop that on. This is the original. That was the first resistor. I put it in the wrong spot, so we're just gonna put that where it should go. Alright, this device is one of the transistors. This is a SOC23. So, just put a little dab. You can see the flux actually spreads out a little bit more to begin with because the board's warm from soldering the previous components. So it'll look just a little bit more runny. place the old transistor. And again, it doesn't have to be perfectly placed, although that's actually not too bad. It's interesting. You can see the warm solder moving around as the temperature changes when after I put the transistor on there. That was kind of cool. Never saw that. It's the surface tension of the solder and the solder mass combined with the size of the solder pads, that's going to pull the component into place, as we'll see here. I'd say it's a little bit too much solder, but that's actually pretty good. You can see it's a little, you can see this is a little bit bulbous, you know, and want more of a kind of like a shoe shape than a bulb, but it's all right. It'll work out. Now we'll see again, surface tension will just pull it right in spot. And a lot of the solder that's kind of off on the mask, it'll get pulled in as well. Not too bad. Make sure I get the right resistor. Alright, and I got these last two large capacitors. These are 22 microfarad capacitors. So again, a bit of solder. Go ahead and do both of these at the same time. I think I put a little too much on that one. We'll find out. Now these match up. So the polarity works a couple ways. One is that you've got the shape outline of the silk screen on the board itself. Should match with the shape of the component, as well as you've got the minus side indicated by the little blob of paint or the black stripe there. And these have tabs underneath. Yeah, just like that. So they're not as easy to get to. You can solder these, like you can see there's a little bit of the tab will stick out, but again, there's always more than one way to do something. Here I want to be a little careful of not actually trying to avoid heating the part itself, so I don't want to just put the heat on there. So I want to put the heat more like on the board itself and to the sides of the capacitor. I had to solder this last component. That's actually going to be through hole. So I was actually going to use the soldering iron. Now I need to hold it from the base out, then you hold it upside down. So I'm going to Just put a little bit of tape there. This is just apply heat, apply solder. Pull the solder away, pull the heat away. Do that again. Apply the heat, apply solder, pull the solder away, pull the heat away. Now a little bit of alcohol. Just go in and give it a good rub down. And there's an extra magnified blinking LED. It's interesting, it just comes from the tiny little die in the center, and the rest of the plastic is as a diffuser. Alright, I hope you liked this video.